Hello. And welcome to our video presentation for our EKC 483 coursework entitled Implication of Octane Number. In this video, we will discuss about the common question that confusing a lot of consumers, and it is about octane number. When we go to the gas station, we will find typically two different grades of fuels which are RON 95 and RON 97. RON is actually stands for research octane number, used to measure the octane rating of a fuel. Those two different grades have different octane number. But the problem arises, what is octane number? The dictionary defines the octane as gasoline rating that indicates how much the fuel can be compressed before it spontaneously ignites. It is not an energy density rating, which it means that a higher octane fuel will not make the fuel last longer than the minimum octane rated for your engine. Many people think that using fuels with higher octane number will give you better engine performance. Actually, that is just not true. Here is the engine combustion chamber of our cars. The internal combustion engine that is in all of our cars has piston and cylinder. The piston moves up the cylinder and compresses the gasoline and air and is then ignited by a spark plug. If the gas ignites due to compression rather than by the spark plug, this causes a condition known as knocking. Knocking can damage an engine, so it is not something you want to have happening. The compression ratio of engine is the amount of compression by piston makes each cycle. Determines the minimum octane ratings for engine requires. One way to increase the horsepower of an engine of a given displacement is to increase its compression ratio. So a high-performance engine, such as Audi, Volvo, etc., will have a higher compression ratio and requires a higher octane fuel. The advantage of a high compression ratio is that it gives your engine a higher horsepower rating for a given engine weight, which makes the engine high performance. The disadvantage is that the gasoline for your engine costs more.
How gasoline additives make your engine work better. Let's tour a common vehicle engine to understand the role and importance of fuel additives. As quality gasoline enters the fuel tank, additives are already at work providing corrosion resistance and fuel stability needed by today's cars. Gas is then delivered to the engine through complex fuel injectors, which often sit just outside the combustion chamber. The fuel injectors must create a very fine mist of gasoline to vaporize effectively in preparation for combustion. Deposit control additives are critical to maintain ideal fuel spray patterns for effective combustion. These additives keep the injector nozzles and surfaces free of deposits. Without them, injectors can easily clog and result in inefficient fuel delivery. During the engine's intake stroke, the intake valve opens and a mixture of gasoline vapor and air is drawn into the combustion chamber. During the compression stroke, the intake valve closes and the piston compresses the fuel. As the piston approaches the top of the cylinder, the spark plug emits a spark and ignites the fuel, forcing the piston back down through its power stroke. Finally, when the piston hits the bottom of its cycle, it starts back up through its exhaust stroke. The exhaust valve opens and the exhaust gases head towards the tailpipe. This four-stroke process of intake, compression, power, and exhaust occurs very quickly, thousands of times per minute, and gasoline deposits can very easily build up on the intake valves. With significant buildup, deposits can actually absorb fuel and prevent the engine from getting the fuel it needs to run efficiently. But in quality gasoline, deposit control additives remove and prevent deposits and keep valves and injectors operating like new. Friction modifiers are yet another type of additive at work in an engine. They reduce the energy that can be lost during the four-stroke process through metal-to-metal friction of moving parts. Friction modifiers in gasoline can provide significant improvements to fuel economy as well as reduce engine wear.
In conclusion, it is the best to use the fuels that meets the octane requirement of the engines. Usually the octane rating for your engine can be obtained from inside of the gas store or the user manual. Using a fuel that has higher octane than needed is just waste of money.